Good afternoon or good morning, depending on where you are. Thank you for joining us today. My name is Tim White. I'm the Vice President of Engineering and Technology at Aerospace Industries Association. I'm joined today by some special guests, and we'll be talking about building the digital thread in aerospace supply chains. As we do so, it would be appropriate for me to express appreciation for the many people who have enabled this to happen, in particular, the AIA comms team and Ananda, who are exceptional professionals. We very much appreciate their professionalism and partnership. Also recognizing the Joint Strategic Quality Council, which is sponsored by AIA and DCMA. And we recognize Gary Mraz and his work in working with that group to bring to fruition results like these that you'll be seeing today. So without further ado, I would very much like to introduce my two panelists today. I've got Doug Cartney with Northrop Grumman Corporation, and I've got Cindy Gagnon with RTX. And as we begin, the first thing I'd like to do is have them introduce themselves. So Doug, if you would, give us a little bit of who you are and what you do.
Thanks, Tim. Really appreciate this opportunity. Like you said, Doug Cartney, Northrop Grumman. Been a part of the aerospace defense industry for going on about 27 years now, and been proud to call Northrop Grumman a home for almost 24 of those. So really excited to be here. I'm our corporate director for quality and mission assurance with the company. Held various roles throughout the company over the years: program management, engineering, operations, and then most recently in this role, serving as quality mission assurance director for our company. So again, really appreciative. Like you mentioned, the QAC, I'm a part of that with Gary Mraz, and looking forward to this conversation here today.
Very good. Cindy.
Yeah. Hello, my name is Cindy Gagnon, and I work at Raytheon. I am leading up the quality analytics and tools team. I got here through various opportunities at Raytheon. I've been here for over 30 years and have enjoyed every minute, but I have filled all the roles of program management, operations, supply chain, parts of engineering. So I'm really excited to be here also. Thank you very much for the opportunity.
Well, it's a pleasure to have you both. I'm excited about the conversation here. And as we begin, let's start at a high level. As people have seen at as we've promoted this content, we're talking about digital thread and model-based engineering, if you will. And we've all heard that a million different times in a million different contexts. Model-based systems engineering and model-based quality assurance and all of these different terms. And there is, frankly, I would say a little bit of hot air around it, a lot of hyperbole, if you will. What we're talking about today, though, I think is very, very real and has some actual legs behind it and real possibility. So, Doug, why don't you kick us off, if you will, talking about what is the digital thread and what is this model-based XX that we're going to be talking about today?
Sure. Thanks, Deb. Yeah, model or the digital thread, we'll start there. It's when we think of it's that entity that kind of connects the program life cycle digitally, starting out the concept definition, going all the way through design, build, test, and even into operations and sustainment. So it's those pieces of data that you get along that whole life cycle that you're looking to kind of stitch together. We look really three sources of truth in that, kind of in that time frame. You get the as designed part of the product design at the beginning, the parts assemblies, the requirements that go into those parts assembly drawings that you might have, any of the other specifications, the technical data. Your as designed really is what kicks it off. You get then into, hey, it's time to go build this. So you get the as-built data that comes along with that product that's going through. So you get your inspection data, your test data, any other fabrication elements, any special process requirements that might get applied into that product as you go along its path. And then third, finally, you get the as fielded. So as that product gets in the field, you can get information back upon its use. It's failure data that you might have from the field. So those three pieces, the as designed, the as built, and the as fielded, kind of really are the sources of truth as you think of this digital thread going through the whole life cycle of a product. I think the thing that's kind of, that also you need to consider is these sources of truth obviously come from a lot of different sources. Some of that's internal, some of that's external. You get different functions in the company that deal with that. You get procurement functions, you get engineering functions, you get manufacturing functions, you get quality functions that all play into that digital source of information. And so this digital thread really helps to connect all those pieces together. You start really with the requirements and go through the designs and the data that comes out of manufacturing. So you put these digital threads in place that help to pull all that information together. That helps better communication back to your internal folks, helps better communication with your customers, better communication even within your supply base as well, if you can all connect in digitally into that whole thread. So, I mean, that's, the ultimate goal is it's going to help you streamline your operations. You don't have to do a lot of handoffs of information, paper designs, or, routing of information. It's all digitally connected within that whole ecosphere, that whole from life cycle, the whole life cycle from project, program concept definition all the way through the sustainment. So I think that's hopefully, kind of as we kind of envision what digital thread means, that's what we're really seeing, that whole stitching of information throughout the life cycle of that product. You also then asked, go ahead.
No, go ahead.
I was going to say, you also asked them what model-based XXX or model-based everything, model-based engineering is. And obviously, that can refer to a lot of different things. You can think about it from the engineering perspective, translating, going from the old 2D drawing systems into a three-dimensional model-based environment where you don't hand off drawings anymore. Everyone works out of those 3D models. You can talk about the simulation of systems instead of, calculations, performance simulations that are kind of done external to product models or product lifecycle management systems. You can build those into those systems and, iterate on your system performance and then build that back into your products as well. So model-based XXX encompasses a lot of things. When we looked at this project that we're going to talk about here in a minute, we recognized that there was maybe a lack of model-based quality in the life cycles of these products. So that was really what we were trying to attack. And that's what, when the JSQC, as you mentioned, kind of kicked this off with us along with TCMA, that was the desires. What do we want to do? How do we make sure that some of the quality parameters that need to be embedded within this digital life cycle, the digital threads, how are we making sure that those are getting stitched in as well? So that's just a little teaser. We're going to talk a little more about that as we go, but I'll hand it back over to you.
Well, that is a great foundation, and I appreciate giving us that overview. Well said, succinctly. So now, as you've teased, we're really talking about digital thread and first article inspection, but there's a nuance maybe. And Cindy, this one is going to be for you. At the very beginning, I talked about, and then Doug talked about the fact that this has been a partnership between AIA and DCMA, which is very much a defense focused organization. My question for you is, we may have people online who are on the civil side of aviation, and I'm interested to have your comment on, does this apply to them as well, or is it strictly a defense approach?
Yes, thank you for the question. So the first article inspection is often a contract requirement. And it is not just for the aerospace and defense industry. The automotive industry and medical industries also use the first articles. So it's really a first article process that's part of the advanced product quality planning requirements, also known as APQP. And what it is, and that actually started in the automotive industry. So it's part of this bigger picture of across the whole industry that we have, across the whole supply chain. So at its core, the FAI process is really verifying that the production process can actually produce the conforming parts that will meet the engineering and manufacturing specifications and requirements. So it does that check that Doug had mentioned between the as built versus as designed and those sources of truth. So it's making sure, again, that it does that bounce digitally for us. So any suppliers that are interested in actually improving their quality should really consider bringing AS 9102 into their quality management system. It just is a really good baseline for the understanding of the product and how it is actually going through the process, and that what you wanted to have actually comes out at the other end.
Yeah, well, that is the objective, and it is part, obviously, to your point, of not just what we do in the aviation sector, but pretty much any sector out there where they're really looking for that tie between the as designed and the as built. That first article is the crucial tie, and now applying digital thread to that is really, I think, going to have some tremendous benefits. But Doug, let me send that back over to you. Can you talk about some of the benefits that you could gain from using a digital thread in a first article context?
Yeah, sure, Tim. And I think you got to start with what first articles look like, have looked like to up until now, and they're evolving over time. But it's usually a lot of paperwork gathering. You have to get a lot of the drawings together. You got to get a lot of the purchase order information. You got to get a lot of the flow downs that were sent to your supply base. You've got to look for your first articles from your supply base as well. It goes into non-conformance reports that you might have had on that first article build. So there's a lot of gathering of information. That's usually what the FAI is at the end of the first production unit or some part of that production run. You go through and you get all this information together. It's coming from different sources. You may only have paper resources to go pull from. You may not even have an IT system in place to go generate some of this information. So when you start thinking then this digital thread that we talked about and the digital connections within that, that's where the benefit really starts to happen. All that work that I just talked about that's usually done way late, you're thinking about it much later than you should be. You didn't think about it earlier on in the product life cycle. This digital model that we've created that we're going to release out there is going to really help to get that information machine readable earlier in the life cycle, and it's going to be more planned and better thought of as you actually establish these requirements on your contracts. The other nice thing about this, Tim, obviously, if you do this right and you think about the life cycle of that product, if it's a digitally in a digital environment, you put these connections in up front for the first time, it'll remain that way as you continue to build this product. A lot of times we get to these points where we had to change something in manufacturing. We maybe even had to change a supplier for a sub-assembly. First article due diligence would say you need to probably go back and look at that. Did that make a fundamental change to as you built this? Did you really still meet the intent of your as designed process? You do this digitally, those sort of connections are already automatically built in. You can get reports out that'll tell you where you might have deltas between what you had built the first time and what you're building now. So that whole benefit of connecting this digitally is pretty tremendous when you think about the amount of efficiency you should gain and some of the human element that we have today that is prone to error or mistakes. You can get some of that out of that process. So I really think of it, Tim, as it's also putting upfront and continuous quality into this. One of the things we always want to ensure is that we're doing is when we're starting out programs, what are the quality parameters? What are the things we need to do to drive quality later on in the life cycle, in the manufacturing processes, in the fielding of the systems as well. So this is one of those really great gains by doing this. You actually build the quality engineers will be working with those team members that are doing the modeling earlier in the life cycle to actually go apply some of these FAI parameters into that same model. So we think that's going to bring a tremendous benefit. We think that's going to, take it from these very human readable forms, and I'll say volumes sometimes of paper that you're actually thumbing through, or even worse, it's sent off to Iron Mountain and you have to go look for it later on in the program life cycle or as you're doing things. So this digital environment, this machine readable information will be much more easy to also get to and access to in the long run as well. So I'll leave it at that.
No, that's a huge, I just can't even emphasize enough what you guys have done here. I mean, when I saw what the team had put out, which is in fact a digital model that facilitates a first article, right? And so it's AS 9102 compliant. It's associated as well with APQP. The applicability to this thing across so many industries and so many companies to me was just absolutely tremendous. And that's why I wanted to get it in front of the AIA membership and kind of broadly the technical community writ large. So I'm really blown away by what you guys have done in making this very, very real. But it does make me wonder a little bit. I'm from a large company background. Doug, you're with a very large company. Cindy, you're with a very large company. Is this only for the bigs? And maybe, Cindy, that question is for you. Talk a little bit about, if you would, if I'm a small supplier, how do I use this? Is this really realistic for me to deploy and use?
Yeah, so that is something that was certainly in the forefront of our minds when we were starting this process. So a few of us that have been around for a little while do remember all of the paper. And for a few of us that have dealt with the supply base, we do have the large suppliers that we all work with. But then there are the 50-person small individual suppliers that have a specialty and don't have that huge IT, DT, digital thread infrastructure. So we wanted to make sure that it was compatible across the board. So we did intentionally design it that way so that all levels of the supply base could be able to use it. So for those that have larger companies like Doug and I, that we do have a full digital structure, and there is digital model-based engineering and such things like that, we are able to use the tool to actually be able to recognize it as something that you can actually take the model itself and insert it into your current digital thread. So that is a very easy plug and play. It goes right there, and then you're able to create those connections to the various data sources that you have. So for some of us, it's going to be a little bit easier. But again, that's, the big players. For the next tier down, we wanted to make sure that they could actually use the model also. So you can actually manually enter the data into the model. And then you can take that and then send that off to your customers. So, that's very nice because it augments the digital connections that maybe your customers do have. And then there's the other small mom and pop shops that we have out there. And we wanted to make sure that even possibly implementing information into the model is going to be difficult. So we said, okay, there's Excel. Everybody uses Excel. So we have the capability to take the Excel format, import it into the model, and then this gives absolutely everybody in the supply base the opportunity to take the information and send it off to the customer, and then the customers can then roll it up. So again, we wanted to make sure across the board that we were not excluding everybody. We wanted this to be completely inclusive of the whole supply base.
Well, that's powerful. So I know in some cases, standards can be costly. And Doug, could you tell me about the cost to use these models? We're talking about actual digital assets that we've invested in creating. Tell me about usage of them. How much do I have to pay to get a copy of this?
Yeah, no, Tim, the intent is, and we've mentioned it's built off of the AS9102 standard, so licensed by SAE, of course, and that's really the cost. The model itself, the SysML model that you would get by having this on your programs, the SysML model we've built, and it's ready to basically lift and shift over into whatever modeling environment you might be using. But obviously, you want to, so that you know how to use the model properly. We have developed a little bit of a guidebook that helps you, from a modeling perspective, how to ingest the model into your own, or as Cindy just mentioned, how do you take advantage of the Excel-based input and to be fair, export capabilities of that model. But you'd want to license out the AS9102 standard, because that gives you a little more of the behind the scenes. Like, here's when we're saying populate this set of information. Here's what that really entails. Where do you go? Maybe perhaps draw that from. So, but it really does. It kind of starts with that. We took that standard and said, let's just go model the outputs of that standard into a nice SysML version. It's pretty minimal. It shouldn't cost too much to get that squared away. So.
Indeed. Yeah. So obviously, if you've got AS9102 as a requirement, you've got to buy that standard anyway. And so this is an incremental, certainly no cost for the model itself, and just a little bit of cost to understand and implement it. So Cindy, this is an exciting topic, right? Because it has applicability to many different industries. It has applicability within aerospace all throughout the entire value cycle, from the very smallest suppliers to the very largest suppliers. How does someone get involved with this? How do we get to the forefront? Because Doug talked about the benefits, and I'm sure that there are many organizations that are saying, let's go do this right now. How can they get involved?
Yes, so we are currently looking for suppliers to go off and pilot the new model to capture their FAIs. So we have the guidebook, as Doug had mentioned. It is ready to assist suppliers that want to pilot and be part of this early stage. And we are a group that is very happy and very passionate about quality-based, um, modeling. So again, very, very happy to engage with anybody that is interested. So we just ask that you reach out to us and we'd be more than happy to work through the details of getting the suite over to you and working with you.
Fantastic. And let me come back to you as you're talking about working with people. Where will the model be eventually? I mean, we're talking about providing it. Where might I be able to get it?
Yes, so it'll be published as part of the data item description, or DID. And it follows the same path that the DoD used to actually create the FAMICA model. And so as part of the AS standard suite, it will also be available as part of the IAQG Supply Chain Management Handbook. So there'll be lots of opportunities to go off and get access to it that way. Yes.
Perfect. So available everywhere, coming soon to
Yeah.
a digital download repository near you. Doug, I did want to circle back a little bit. We talked a little bit about the fact that the model itself is going to be freely available, but can we drill in a little bit on what kind of labor do you really anticipate needing in order to make this thing real?
Yeah, certainly, Tim. And that's one of the things that we addressed in the guidebook, because we really thought about that from the way you conduct business now for doing FAIs. You live in a world a couple of years from now where this becomes more prevalent. You're going to see it flowed down in contracts to the primes, down to the supply base, and what's that going to look like? What's that really going to mean? So we did try to address, what does it mean from if you're taking it in as a prime level, you're negotiating, say, the DID with your government customer. How do you want this to look on your prime contract? The labor efforts that you have there, and then subsequently, as you flow it down into your supply chain, second, third, fourth, fifth layers as required, what does that really look like? So we anticipate, like I kind of mentioned, the overall benefit, Tim. Yeah, there's still effort. This doesn't just magically poof, you just apply this model and all of a sudden everyone can just walk away and assume it's going to work. You're still going to have to apply some what I'll call engineering, quality engineering, probably systems engineering effort up at the beginning to think about how this is going to actually live within your product models. But once you get those established and you get the connections made to whatever digital systems, the other threads of information you might have within your environment, then that effort that you used to do where you had to go pull that information manually at the end of things, those are going to start to go away. So you would expect maybe it's a shifting of labor, not from the back end, but more up towards the front end, is from, I'd say, a prime perspective. From the supply-based perspective, if you don't have the capability of working in that same sort of a modeling environment where you could do those more upfront things and then walk away a little bit more towards the end, Cindy and the rest of us, we really said, we don't want this to become an extra burden on the supply base. And that's why we really wanted it to be this kind of, hey, everyone has an Excel-based version of this tool that you could provide inputs into this system. It'll help the primes because then we don't have to go manually input some information as well. So I think from a supply-based perspective, it should be a minimal, if to zero impact in terms of what we anticipate their level of effort would be to provide the digital data that we need to ingest into the models as they roll up to the higher and higher levels of assemblies. So I think that's kind of in a nutshell how we're kind of seeing it play out, Tim. I think the back end benefit too, if you start thinking about the Delta FAIs that we traditionally have to do, those, like I said at the beginning, if you do this correctly, those become much easier as well at the end, because you've already connected within your systems all these sources of information. If the suppliers changes for one of the parts that you're buying, well, your digital system's going to know that. So it's going to populate that in your system model. You're going to realize, hey, there's a difference between unit number 3 I did the first article on and say unit 100. There's a change in supply source. You can then go quickly look and say, is that going to be a risk? Do we need to go back and validate that the as built is really meeting the intent of the as design? So I think it can also be a little bit of an efficiency gain on the Delta FAI perspective too. Talked about a little bit in the guidebook what that might look like, but I think that'll be something that we'll kind of experience as this gets a little bit more deployed on the first time uses as we go forward.
Well, that's fantastic. So kind of one last question and really looking into the future, both near term as well as a little bit further term. Doug, if you would close us out with, we've talked about the fact that here we are, we have this model. I've seen the model because I'm inside the group, and it's an exciting capability, but we've also talked about the fact that it isn't yet publicly available, but it will be soon. So give me a little bit of preview as to when soon and what that looks like. And then, if you will, take us into the future a little bit. This is a big deal, but what's the next big deal that the group has looked at?
Yeah, and like Cindy mentioned, we're near that finish line of actually getting all the, I'll say, I's dotted, T's crossed to allow it to be at least adjudicated and for review into the DoD's DLA Assist website that allows you to download the DIDs, and that's really where that's where this is gonna live at the end of the day. So once we get those last little sign-offs done, the DID will sit out there. We anticipate that that'll happen sometime this fall. Once we get all the I's dotted, T's crossed, like Cindy said, we really can start getting more active participation in pilot programs. So it's imminent. We've been working on it for about the past year. Kicked this off about July, August of 23. Had a lot of good modeling effort throughout the fall and winter time and into spring, and then really started finally honing in on the actual data deliverables that came out of this project. So we were very close to having it come across the finish line when it comes to that. So but that didn't mean we stopped. Just like you said, we always envisioned this working group, this model-based quality working group. FAI was just the first one of probably many different activities that we sought after or that we were going to go explore. So the next one that we've teed up is we're going to look at how to potentially do digital modeling of the certificates of conformance. Those usually go into your FAIs. So it seemed like a natural progression. Well, how do you maybe put that in digitized information so you can have that part of your modeling as well? And we've talked about other elements, like Cindy mentioned, of the APQP process. There are many different aspects of APQP that could lend themselves to a digital thread environment. FAI is one of those, and there's other elements within there that probably could become a more common digital environment, common digital model that we could employ that would help to, simplify, if you want to call it that, the PPAP process that you follow on at the end of APQP, where you ingest those, data items that go along with the product, so you can see its heritage and its buildup and the measurements used to validate its product structure. So there's a lot of different things that we've talked about that we can continue to go forward. And to be fair, we'd love to hear from the industry too. If there's things, we obviously have a broad team of across the industry within these working groups for the JSQC, but anyone that's an AIA team member should also feel like they can raise their hand, bring it back through your QAC rep and bring it up to our level, and we'd be happy to look at it as a potential for modeling as well.
Well, that is fantastic. I appreciate that. So let me see if I can tie this up in a bow with a couple of statements, and that is that we've actually leveraged the concepts and principles in model-based XX and digital thread to create a digital model of the first article inspection that is compliant to AS 9102 as well as compliant to APQP. And that model is going to be available very, very shortly. It's applicable to both the defense as well as the civil side of aerospace, but also in broader communities, broader industries as well. And so I think that this is a tremendous opportunity to increase quality, increase velocity of the activities that we're really undertaking to ensure the safety, certainly, of aviation and defense. And I'm really excited to see this continue on and eventually encompass more and more and more of the elements of quality data. And I'm confident that as it happens that way, that we will continue to march forward and deliver to our customers the assurance that they're seeking for. So my thanks to Doug and Cindy. Thank you for being not just here today, but for your expertise, as you pointed out, for the last year and a half now, and certainly the expertise that your team brings as well. We're so pleased and proud of the work that has gone on there. One of the things that I would invite folks who are either watching live or who may watch this later is if you have questions, if you would like to personally be involved, if you want your company to be involved, please reach out to me and I will forward you along to Doug and Cindy and the excellent team over within the JSQC and the QAC. So with that, I will say thank you for joining. Thank you for watching. Thank you to the panelists and have a fantastic day. We'll look forward to talking about the deployment of this in the very near future.
Thank you, Tim.